evaluate this double integral. But the integrand, hopefully you notice, is troublesome. It's e to the x squared plus y squared. You can think about it as e to the x squared times e to the y squared. And the point is that it prohibits you from being able to do it as a dy dx integral. The region ends up circular in nature, and so that's going to lead us to switch this xy Cartesian double integral to a polar double integral. The y's are between, on the low end, y equals 0, that's the x-axis. On the high end, y equals the square root of 4 minus x squared. And then x's are between minus 2 and 2. Negative 2 and 2. Okay, so what is this region? It is the semicircular region. The equation y equals the square root of 4 minus x squared. We square both sides to get that y squared is equal to 4 minus x squared, or that x squared plus y squared is equal to 4. Circle radius 2. So we have a circle of radius 2. But only the top part of it. Imagine that's a circle. It doesn't look like one. But minus 2 to 2. X's go from minus 2 to 2. And Y's go from 0 up to the semicircle. And instead, though, we're going to go with polar, where we use radial lines coming out of the origin, and we rotate those guys in terms of theta. And so we have the equation of the circle is r equals 2. We have x squared plus y squared, which is r squared, equals 4. We don't do plus or minus with r. We just r is equal to 2 is the equation of the circle centered at the origin with the radius of 2. So r's go from 0 to 2. What about theta? Well, we start with theta equals 0, and we're done by the time that theta equals pi. Here theta is pi, here theta is 0. What about the integrand? E to the x squared plus y squared. We know x squared plus y squared is r squared, so that's e to the r squared. What about dy dx? That becomes r dr d theta. Without the r there, we're in the same boat as we were when we began. But now that we have the r there, we can do a u substitution. What's the exponent on e is 1 degree higher than the other part of the integrand. So by letting u be r squared, then du is 2r dr, so that half of du is going to take the place of r dr. And we'll have 1/2 the integral of e to the u du, which is 1/2 e to the u. So, converting back, we're going to have this outside integral, 0 to pi, and then 1/2 e to the r squared from 0 to 2. So then we have plug in a 2, plug in a 0. Leave the half all the way out. So we have 1/2 the integral from 0 to pi, e to the r squared, or r is 2, so e to the 4 minus e to the 0. Now that's just a constant in terms of theta. And so that can come out along with the 1/2 as 1/2 of e to the 4 minus 1. And then we're just looking at the integral from 0 to pi of d theta, which is just pi. It's theta from 0 to pi, which is pi minus 0, or just pi. For a final answer of, multiply that by the half and call it pi over 2, the quantity of e to the 4 minus 1. That would be your final answer, and that corresponds to letter E. Very good.